A polynomial is basically just an expression that can have constants, variables, and exponents. You don't want it to have something like a square root, and you don't want it to have x in the denominator. So like you could do x divided by 2 where it's on top, but not 2 over x. Because that's technically something called a negative exponent. We don't want those. This second one, I know sounds super funky to people, but it's technically in the definition of a polynomial, so I want to talk about it. A finite number means that it has to end. So like it can't just say that it has an unlimited number of terms. You have to be able to see the end of the polynomial, which means that it's going to look pretty normal to us. It would look very abnormal if it was going to have an infinite number of terms. And then these two are the same thing. Okay, the exponents can only be positive whole numbers. So like 1, 2, 3, 4, 5. Not negative 1 or negative 2, and not 1/2 or 3/2 or 3/4. So no fractions or decimals, no negatives, just positive whole numbers. And I don't know when whole numbers gets taught, but I realized I've said that quite a few times, and some people are looking at me like I'm a little bit from another planet. Whole numbers means the ones we like that don't have fractions or decimals. Okay. Technically, whole numbers are also already only positive, but since I know not everybody knows the definition, I added the word positive out there too. So that's kind of a redundant part. Okay. When we write polynomials, we are going to write them in standard form. This isn't anything super fancy. It doesn't have a formula. You're just going to write it from highest exponents to lowest, which we've already been doing. When we did quadratics, we wrote x squared, then x, then the number. We're going to do the same thing here. It just might get into some higher exponents. Okay, so it makes the most sense to write your highest exponents first, then your lowest. Okay, and pretty much what we're going to start off with is something called combined like terms, which you've probably already seen. Get that back out. Okay, so what we're going to do is add or subtract the coefficients. Coefficients means the numbers out front of like terms. This means that they have to have the same variable and the same power. I don't think anybody doesn't know this, but it can get a little confusing. It just means you add the numbers out front, and that's it. You do not change the exponents, or you don't change the variables themselves. Okay, just the number out front gets changed. One of the reasons I'm saying that is because when we get to multiplying, we add the exponents, and people get confused between adding and multiplying. In fact, a couple of us did that on our test, and then realized it and went back and fixed it a little bit. There really isn't too much I'm going to give you guys as far as a method goes, but I do have a suggestion. Combine like terms in order from highest to lowest exponent, so that A, you have an order for yourself, and B, it's already going to be in standard form, like it's supposed to be. So you don't have to worry about that afterwards. Okay, here's what I mean by that. As I'm looking through this first problem, I'm going to look for the highest exponent I see. Remember that exponents have to be the little numbers up top. And the highest one that I see is this one right here. And there's no other x cubes. So that one does not have any friends to combine with. It's just going to come right out here in the front. And that negative that's in front of the 5 has to stay with it. Remembering that negative is one of the hardest parts because a lot of times you just see the 5. Then after 3, my next highest exponent would be 2. So then I'm going to circle all the x squareds. And you'll notice that these aren't in the same order on both sides. That's why going from highest to lowest helps. So now I have 3 plus 8, which is 11. Keep the x squared after it. And that's all we're doing, guys. I'm going to keep going through this one, but that's basically the idea right there. After x squared would become just x, or x to the first power. So negative 9 plus 4 is negative 5. And then the 11 at the end. And you'll notice that both of the ones I did at the beginning and the end, and the blue, these are two that didn't end up changing, and that's okay. However, that is the part that confuses people on this one, is they don't like that not everything has something to be added with. It doesn't always work out all hunky-dory and we all have something to add to. And that's it. That's all we're doing. If there is a subtraction symbol instead of an addition symbol like this, my suggestion to you, some of you are going to not follow this, and that's fine if that's your prerogative to not listen to what your teacher is suggesting, is to take this negative and multiply it the rest of the way through. So that way you don't have to worry that you're subtracting negative 2x squared later. So I'm just going to multiply everything by a negative, which changes all of the signs. And the reason why people don't like to do this is because it does take a second to write it down. But now you don't have to worry about the signs anymore. In fact, I'm going to cross out what was originally there and do the exact same thing I just did on the left side. That is the only difference between adding and subtracting. You do have to pay attention to the sign in the middle, though. I'm going to start with my highest exponent, which looking across looks like it's a 3 again. I have a 4x to the third and a negative 2x to the third. And 4 minus 2 is 2. And then I'm going to go x squareds. There's only one of them, and it's a 2. So plus 2x squared. And then my x's, I have a 7x here and a negative 8x here. 7 minus 8 is negative 1x. And my regular numbers, or my constants, negative 3 plus 5. Okay. You can also double check at the very end to make sure you have circled everything. That way you know for sure nothing got left behind. Okay. All of these things that I've been telling you are things to help you with the small details. Because there's a lot of moving pieces, it's not that hard. You do have to go slow enough and be careful enough to make sure you're not going to make a silly mistake. And now we're going to move on to multiplying. There are some special multiplying rules we are going to talk about on the back side. We've already seen them at least 2 or 3 times before because they were in factoring and multiplying in quadratics. There are really 3 main rules to keep in mind. The main thing you're going to be doing as you multiply is you're going to be adding your exponents. A lot of times we won't stop and think about that. It'll just kind of happen naturally. Like x times x is x squared. You're technically adding the exponents there. I'm just kind of leaving that there in case you get something more complicated later on. And then you're going to multiply any of the regular numbers. So coefficients and constants, these are the regular numbers. Versus the exponents, which are the little ones up top. Those get added, regular numbers still get multiplied because we're multiplying polynomials. The second rule is if you're missing powers of x, you may want to replace them with a 0. This is called a 0 placeholder, and I'll show you what that looks like. It'll make more sense once we get to a problem. We've never done that before. You'll see why it actually makes a difference. And then the third thing is if you are multiplying things with more than 2 terms, you may want to use a box to organize yourself. And we've never done the box method together before because we know how to multiply without it, But when we get to things like these last two on the right, those are big enough answers that they're going to have a lot of pieces. And I'll show you what the box method looks like on those. You do not have to use it. It is just something to help you stay organized. So on the left, this is actually an exact problem that came out of Unit 3. You're going to take this 2x and multiply it to the 5x and to the negative 3. We're distributing. 2 times 5 is 10. X times x is x squared. So that first one is going to be 10x squared. 2x times negative 3 is negative 6x. Do the same thing with 4. Multiply it by both of them. Okay. This is probably not something that I taught you that was brand new. It was more something you probably came with. Just make sure this gets multiplied by both, and this gets multiplied by both. And then there's always going to be a spot in the middle. You can add them together on this type. These two. The nice thing about it now is you don't have to worry about i's. So that is just your answer, like that. When we did this last unit with x's and with i's, a lot of us got a little freaked out when we did it with the i's stuff. And that's your answer right there. Okay. We are going to start multiplying polynomials that are a little bit bigger together. And what this means is that, and I'm not actually going to draw this. Actually, I'll grab a pencil and draw this because it looks kind of complicated and I don't want to leave it up there the whole time. This x squared would have to get multiplied by all three of those. Then the 3x would have to get multiplied by all three of those. And then the 1 would have to get multiplied by all three of those. So we have 9 things we have to multiply, and it's going to get kind of lengthy. So what I suggest you do instead is write this one down below, x squared, 3x, and 1. You don't have to write the plus signs, but you can if you want to. And then we're going to write the other one going down, like this. And we're going to make a box with a column at every plus sign or minus sign, and a row underneath every term, like that. And then we're going to fill in this box by multiplying the two things that intersect there. So like this top left one will be x squared times x squared. That way you don't forget to multiply two of the things together. It's really hard to keep track of. However, if you're good at using mental math and you don't need to draw the little arcs each time, you could easily take x squared and multiply it by these 3, and then write your answer down, and then do the same thing with 3x. But you end up doing the same thing I'm about to do anyway, which is add these two exponents together. That makes 4. So we have x to the 4. And then 3x times x squared is going to be 3x cubed. That has an imaginary exponent of 1, if that helps. And then 1 times x squared is just x squared. So we're doing the same multiplying. I still multiplied x squared by the other one. But I'm writing it out like this so that later I can add my like terms. Negative 5x times x squared is negative 5x cubed. Negative 5 times 3 is negative 15. X times x is x squared. And 1 times negative 5x is negative 5x. And then I'm going to fill in the bottom part so you guys can see it. Let me know if you want me to repeat part of that. That's honestly a part that's easier maybe to just write down and look back for a second. I'll give you a second to make sure that makes sense to you. I'm taking this 2 and multiplying it by all of these. And then the like terms, the whole point of the box is that now your like terms are here. X cubed, X squared, and X's. So you don't have to go searching all over your problem to find them. So my final answer is going to be the x to the fourth, and then negative 5x cubed plus 3x cubed is negative 2x cubed. And I have a little bit of work to do in the middle. 2 minus 15 is negative 13, plus 1 is negative 12x squared. 6 minus 5 is 1, and then the 2 stays on the end. And that's my answer. Okay. How are we feeling about that one? Okay, if you absolutely hate that box, you don't have to use it, but I will say you can also just not write these two parts if you don't want to. If you just want to set these up on your own without drawing the lines and the outside pieces, you can still use the idea behind the box method without drawing all the extra pieces that tend to annoy people. Okay, I'm going to do this last one on the right, except I'm going to say one thing before I get it started. This one doesn't have any x's in the middle. So I'm going to put a 0x right there. This is only necessary if you want to use the box method. Because if you don't have the 0x, then your like terms aren't going to add up quite as nicely as they would have otherwise. Okay, so then I'm going to do the same thing, x squared plus 3x plus 1 along the top, and x squared plus 0x minus 2 down the side. And it doesn't matter which one you put where. You just need to write them both out. Okay. And then I'm multiplying the top row by x squared, which is just going to add 2 to my exponents. So once you get used to what you're doing, you just take that number and multiply it by all of them. It actually goes pretty quick. And then I'm taking 0, multiplying it by all of them. I'm still going to write my exponents just to kind of make sure I'm doing things correctly. If my exponents didn't line up, then I know I've got something wrong. And then negative 2 just multiplies whatever's out front by negative 2, but it doesn't change any of my exponents. And I can add together my like terms in each diagonal. And it will always end up being the diagonals if you use your 0 placeholder. Okay, x to the fourth stays. 3 plus 0 is just 3x cubed. Negative 2 plus 0 plus 1 is negative 1x squared. Negative 6 plus 0 is just negative 6. And then there's a negative 2 at the end. Okay. Any questions before we run to the back side? Okay. On the back side is our special cases, or special patterns, I think I call them. Yeah, special patterns. We've talked about these. They can also save you some time. Okay, for instance, on this one, when I multiply 4x times 4x, I'm going to get 16x squared. And these only have 2 terms, so I'm not going to use the box. I'm only going to use the box when it gets lengthy. 4x times 3 is 12x. And then we do the same thing with the negative 3 times 4x. 12. Negative 3 times 3 is negative 9. But when we multiply two things that have the same parentheses, the sign is just different, the middle terms are always going to go away. And what you're going to be left with every time is the first one squared and then the second one squared. And they're always going to be subtracted. That last one's always going to be negative because it was a negative times a positive. So if you ever see these two things and you don't want to do this stuff in the middle, means you know these are going to cancel out, just square this one and square this one and subtract it. Because that'll happen every time. If they have the same sign, that's what we would call a perfect squared trinomial, where it's really the same parentheses next to itself or squared. Whenever you see that little squared, it means you're doing this, multiplying it by itself. The only difference here is that these two in the middle are both positive, so they don't cancel. So we're going to have 25x squared. 5x times 2 is 10x. 2 times 5x is also 10x. And 2 times 2 is 4. And then you have to add them together in the middle. The pattern here is that it's this one squared and this one squared, like you might think. And in the middle, all you have to do to get that number, if you don't want to write it out like this, is multiply these two things together and double your answer. So 5x times 2 is 10x, times 2 is 20x. It's always 2 times though because there's 2 of them in the middle that get added together. That's it. So you could use that special pattern if you wanted to. I'm only going to do one of these last two because really the only thing I'm trying to tell you in this last section is it can give you multiple operations, and when you're trying to decide which ones to do first, follow the order of operations. You might have heard of it as PEMDAS before. I call it Gemdas because parentheses aren't the only things that group things together. You can have a square root or a fraction bar or something. So I use G for grouping instead of parentheses. But what you're going to do is multiply this out together here and then subtract this. That's it. And I put one kind of like this on your guys' test. So I'm going to show you how to do this one without the box method just because I know there's people who prefer it and because this one's a little bit smaller. So I'm going to multiply everything by x, which is going to, again, add a power. 3x cubed, 2x squared, negative 1x. And then I'm going to multiply everything by 2. This one doesn't change the powers though, it just changes the numbers out front. And this is what I meant by you can do the box method without drawing the whole box. So I kind of did the same thing. Here's my x squared. Here's my x's. So that's going to be 3x cubed, 4x squared, 3x minus 2. And then I'm going to go ahead and write this next to it, minus 5x squared plus 3x minus 11. So I'm multiplying that negative. And then I just add my right terms. I'm taking this negative and multiplying it.
Oh, I see.
Yeah. And that's why I do it, is because that negative and that 11 are so far apart that your brain is not going to realize that they go together unless you multiply the parentheses all the way through, that negative all the way through. So we got our x squareds. 4 minus 5 is negative 1. We'll leave the 3x to the third up front because there's no others. And then 3x plus 3x is 6x. And negative 2 minus 11 is negative 13. Okay.